Hello, this is going to be a pretty in-depth look at momentum in two directions or two dimensions. We're going to start with what's really nice about this simulation here is they give you the f of x values, the f of y values, the p of x values, and the p of y values. So let's use those to help us find the velocity, this v1 here, this vector. Okay, so right here is going to be our v1 of x, and right here will be our v1y, which we know the values down there. And so then you're going to want to make your triangle. So this is your v1x. This is going to be your v1, and this is going to be your v1y. Okay, so now what we're going to use is Pythagorean theorem to solve for v1. We don't know any angles, but we do know two sides, so the square root of v1x squared plus v1y squared is going to equal v1, so we can calculate that. So our velocity for our first ball is going to be 1.044 meters per second. Okay. So then we can use that velocity and solve for our momentum for that ball by taking the equation for momentum, mass times velocity, which in this case is m1 times v1. So let's solve for that. What we get is 0.522 kilograms times meters per second. So let's keep that momentum in mind and put it all the way up here. So P1 equals 0.522 kilograms times meters per second. All right, and let's get rid of all that velocity stuff and double check our work by doing kind of the exact same thing. But this time we're going to use velocity, or this time we're going to use momentum instead of velocity. All right, so this is going to be our momentum in the x direction, so p1x, and our momentum in the y direction, so p1y. Again, make a triangle over here, but this time with momentum, so this is p1x, and this is our momentum 1, and then p1y. Again, the Pythagorean theorem, so p1 is going to equal the square root of p1x squared plus p1y squared. And we can solve for that. And when we solve for that, we get our momentum to equal 0.522 kilograms times meters per second, which if you look, these two numbers right here are the same. So did I have to go through all that work of velocity in two dimensions? If the momentum values are given to me, no, you do not. But it's a good way to double check your work, and it's good practice at doing that stuff. So now that we have this momentum value, I actually want to know at what angle this is. Okay, so what we're going to do is then solve for that angle. So let's erase, because we know what the momentum is. Let's erase a lot of this. Let's keep our triangle. And so I want to know what that unknown angle is. And so I could use SOHCAHTOA in whichever way I want, but I'm going to do cosine, right, of that angle is going to equal P1 x over P1. And so we want to solve for this by itself. So what we're going to get is ultimately here, so you can put it in your calculator, is this cosine negative 1. It's going to be the P1x over the P1. So if you're doing your 5 steps, this equation right here is what you're going to use as your correct equation in the 5 steps. Okay, I don't have room on this to do all those 5 steps. So we can solve for that value by plugging in our known. So once we solve for this, our angle is going to be 16.694 degrees, and that's going to be north of east, which makes our final answer for the momentum of object 1, the initial momentum. So this is really P1 initial. Okay, it's going to be 0.522 kilograms times meters per second, 16.694 degrees north of east. So now I want to solve for the initial momentum of object 2, so P2 initial, and we'll just skip the velocity one on this one and make a triangle out of this where our P of y, P2 of y is there, and our P2 of x is there. And so now we're going to make a triangle out of this, and so we have our P2y, we're going to have our P2, and we're going to have our P2x there, Pythagorean theorem, and I'll solve for that. So our P2 initial is going to equal 1.061 kilograms times meters per second. And then what we're going to want to do is I want to find the angle between momentum and P of 2y, and so I'm going to use cosine theta, which is our angle, our unknown angle, is going to be P2 of y over P2. I'm going to rearrange that and solve for theta. And if you do the math, a theta is 45 degrees, which makes sense because both our momentums are the same value, which would mean it have to be a 45, 45, 90 degree angle triangle, okay, because both sides are the same. And so then that would mean we go up here, 45 degrees, and in this case, it's going to be west of south, because it's this angle right here. So now we have our two initial momentums. So what I'm going to do is now run the simulation and see what we can do once you have these two objects moving in two directions, okay, momentum is conserved, especially when we have an elastic collision, which we see over here. Okay, that means that the momentum isn't going into the environment. So we're going to press play, see what happens, and then calculate for our final momentums. Okay. So now we have them collided, and now they have new momentums because they've collided with each other. And so we can solve using the new values for this. And so what I want to find is the momentum of object 1, the final momentum. So to do that, again, I'm going to have to make a triangle. Okay, we have our P of X here. Values are down below if you need to look. You have your P of Y here. And really what is it? It's P1 of X, P1 of final. You could put initials in there to get more complicated. So let's make a triangle. Out of that, we have P1 Y P1 X, and then we have our P1 final here. So again, use Pythagorean theorem to deal with this. So we're going to deal with Pythagorean theorem again to solve our P1 final. Is going to be our P1 final is going to be 0.751, that's rounded, kilograms times meters per second. And then we need to find its angle. And remember, to find its angle, we want the angle, let's go from the angle between DOY. So we're going to do cosine theta equals P1Y over P1 final. And I can solve for theta. Alright, so for the angle, you get 63.849 west of south. Alright, so we found out the angle was, or the momentum was 0.75, 63.849 west of south. So now let's find out what it is for our object 2's final momentum. Okay, so again, you make a little triangle, x direction, y, make it into a triangle. So we have our P2 of x, and we have our P2 final, and then we have our P2 in the y direction. And we can solve using Pythagorean theorem, and so let's solve. Alright, so now we have 0.502 kilograms times meters per second, and then we can find out the angle. Find out the angle of right there by doing cosine theta equals P2x over P2 final. So theta is going to equal, solve for that. It's going to equal 32.369 to be 3629 south of east. So now we have our initials and our final momentum. So we have found their initial and their final momentums in the directions that they were traveling.